So in this question, we need to evaluate this sigma. So we need to find the sum of I plus j, and we need to do it twice. Okay. So so if I put a bracket somewhere, like that, and then try out the expression within the bracket first. So sigma j equals 1 to 100 I plus j. So we can simply write it as I plus 1 plus I plus 2 and so on up to I plus 100. And then that would be equal to 100i plus 1 plus 2 and so on up to 100. So then you can find the sum to n terms, so sum to 100 terms, and then 100i remains as it is. So when we add the sum, use the n out of 2, that sum to n terms is n out of 2 times first term plus last term. That's what I have used here. Okay, so the first term is 1, the last term is 100, so 1 plus 100, and what we get is 100i plus 5050. And then now what we do is, instead of this term, we replace it with this term, 100i plus 5050, and we do the summation again. So I could write it as that, and I would have to do the sum again. So it would be, now I remove the bracket, with sigma I equals 1 to 100. Previously we had j, so I equals 1 to 100, 100i plus sigma I equals 1 to 100, 5050. And that can be written as 100 times 1 plus 100 times 2 and so on up to 100 times 100, and plus 5050 times 100. This gets written 100 times, So if you were to add that once more using the sum to n terms formula here, because it's 100 times 1 plus 2 plus and so on up to 100, so that's why we have the sum to n terms formula again, and 5050 times 100 is 505,000. So our final answer is going to be 1010,000, so 1,010,000. So this is the answer.